Today we will discuss about printing a two-dimensional array in the spiral order. So the spiral order means the printing should be from uh, like this. So this is a spiral order. Um, when we draw the spiral, so we can clearly say that we need to follow four directions over here. That is from left to right, top to bottom, and right to left, and bottom to top. So we definitely have need to keep track of the directions and the rows. For suppose we have printed first left to right, and we should not consider the first row again, it is done. And the next left to right should be this part, and the same top to bottom we should take out this, and the next top to bottom should be this part. In order to make this, we need to keep track of the directions and also the rows and column values. In this case, I want to define four variables called top, bottom, left, and right. So this is the topmost um, row, and this is the bottommost row. This is top, this is bottom, and this is the leftmost column, and this is the rightmost column. So if we can keep track of these directions, we can easily by incrementing or decrementing the values of these TBLR, we can keep track of the unvisited rows and columns. And also if we can have a variable called direction, so in this case I'm just defining a variable like direction 0 and 1 2 3. Here the 0 means left to right, and 1 means top to bottom, 2 means right to left, 3 means bottom to top. So if we can keep track of these directions, once we print the first row we will change the direction to 1 so that it will print from top to bottom. Once we are done with, we'll change the direction to 2 so that it will go from right to left, and then we'll change it to 3, then it will go to bottom to top. So this is my idea. uh, this is my idea. So let me start coding it. Maybe during the coding we'll have more idea. mm, Now, one more thing, we need to for how long we need to do this increments and decrements of the T and B. We need to have that condition, exit condition. The exit is nothing but as long as this top bottom are equal and the left right are equal. So as long as these two are equal, we need to do. So when we end up here, the top and bottom, the left and right will be at the same place. So the condition will be, let me start from the first. We'll print spiral order. We will be given an array A, and for suppose the rows and columns. What do we need to do initially? We need to define the values of the top, bottom, left, and row. So T is the topmost row, so T will be the 0. Bottom, what is the bottommost? If the number of rows are m, then this will be m minus 1. And the leftmost will be 0, and R, the r rightmost will be n minus 1. So these are the defined values for the top, bottom, left and right values. Now, and as we have discussed before, we will have a direction variable. Initially we'll set it as 0 because as we have discussed, 0 is from left to right, and then keep on changing the directions to 1, 2, 3 and 4. So the direction is 0. Let's start with the condition. Top less than or equal to bottom and left less than or equal to r. We'll start printing the elements. First, if the direction is 0, then we need to print left to right. So the condition will be for int I equal to left, I less than or equal to right, I plus plus console dot write line a of. Now, so we need to print this one means the rows keep on, the row will be the same, that is top, but the columns will keep on changing, the column value will be I. So this will be a t of I. Once we print this row, the top should come to the next place. That means it should be here in case it's 0, now it should be incremented. Once the for loop is done, we need to increment the t value, and what we need to do, we need to change the direction to top to bottom. So the direction will also be changed. This is if direction is 0. Else if direction is 1, now what, direction is 1, now top to bottom. So top to bottom, top to bottom, how we will print top to bottom means the row number will be changed but the column will remain the same. What is the column here? L is the column. The rows will be changed. Oh, sorry, this is the one. What is the column? R is the column. So R will be the same, but here I will be this one. So the concept is A of I R. Once we are done with this, R should go here. That means we are decrementing the R value, R minus minus. And again we need to change the direction to 2. 2 means now right to left. Now just short of space, so I'm just writing over here. Oh, maybe, yeah, I can do this. If direction is 2, what we will do, the direction is 2, now that is right to left. So I greater than or equal to right to left, I minus minus, in this case what will change, column values will change but the row is constant. The row here is B. So A of B I. Once it is done, we need to decrement the value of B. So B minus minus, and then we need to change the direction, and the direction will be 3. Once the direction is 3, now the condition, what is the, if direction is 3, we need to go from bottom to top. Again, this is decrementing, right? So it should be the condition bottom to top. When we are going to bottom to top, what is the value that is what is the value that is staying intact? That is the column value, but the rows are getting decreased. So that is L here. So A of I L. Once it is done, L needs to be incremented. So L will be L plus plus, and we need to make the direction again to 0. This keep on happening while this condition is true. Again it will go to direction 0, it will print this line now, and then it will eliminate this, and then it will go print this, and then it will print this, and then it will print this, like that. So this is it.